Right, figure it out. So you found the classroom, that's a good start. You found the time, that's a good start. We can talk about my office hours. So I am required by Eastern to offer 4 hours of office hours. I find in general that is too few. So I will be offering 10 hours of office hours per week because I can. And also office hours are probably my favorite part of the job. As much as I like teaching to a large classroom, it's not as one-on-one as I think that the best learning happens when you're able to ask the exact question that's on your mind, get answers to that in real time with real feedback. So I find office hours to be incredibly important to the learning experience. So I offer as many of them as I think my schedule can allow. So my office hours will be 11 to noon and 1 to 2 every weekday, Monday through Friday, every day that this class meets. I do this so that people can get that individual attention, so that I can make sure that you get the best opportunity that you can to get as much out of this class as you can. In addition to my office hours, we have a phenomenal TA in the course who will also introduce himself and talk about his office hours.
Hi, I'm Hunter. I'm a grad student here, and I'm the TA for the class. My office hours, also every weekday, I'm here from 9 to 10. I'm also here during the class, but unless you're skipping class for whatever reason and also need help at the same time, that probably won't matter. But yeah, 9 to 10 every day for office hours if you need some help like before class or anything.
He's fantastic. He's TA'd for this course before. He knows the material really, really well. So feel free to reach out to him or reach out to me. If my office hours don't work for you for any reason, please just send me an email. I will find a time to meet with you. It is probably my highest priority here. If you have a question, that it gets answered. I'll talk about the rest of the policies, but I just want to start the class by saying I am accessible. I love working individually with students. So please, if there's anything that I can do for you throughout the course of the quarter, please don't hesitate to swing by my office. It's CAP 334. It's just on the other side of the building, along with all the other professors. So what are we going to be doing in here? It's a pretty natural extension to programming 2. We are going to, instead of now talking about the features of Java so much, we're going to start learning how to store and retrieve data efficiently. So it's an extremely important topic. The textbook for the course is Data Structures and Algorithms in Java. It is optional, but I highly recommend it, especially because now most people around here don't know this, but Peter Drake was my professor. I don't ship his book. We have historically used this book in this course. When I was doing a review of what materials have historically been used in this course, I was like, wow, my old professor's textbook. This is so cool. So yes, I know Peter Drake personally. His book is phenomenal. I was taking his courses while he was writing this book. So we have quite a good history. He's a very, very good guy and knows his stuff very well. He's the person that I took data structures from. So it's a natural, historical, I don't know, call it whatever you want. But it's a great book. I highly recommend it. You should be able to find it reasonably. It's old enough that it should be fairly cheap. Policies for the course. I do prefer, if you have some kind of question that I can work with you in person, come ask it in office hours. But of course, email is available as well. It, especially in non-weekday hours, is difficult for me to get to emails reasonably quickly. So please let me or give me about 24 hours to respond to an email. If I have not responded within 24 hours, it probably means that something happened and it fell down my queue and it may have slipped past. This happens from time to time. It's not personal, it's not intentional. I just unfortunately have a lot on my plate. So if that happens, please just send me a reminder email with that. Note that though, if you are sending that email reasonably soon before an exam or a deadline, I may not have the ability to respond before that is due. I will do everything in my power to respond to that, but I am a pretty busy person, so if that does not happen, I can't guarantee it. The better way to handle those kinds of questions is to come see me or the TA in office hours. I make it sound like I never get around to emails. I get around to almost all of those. It's just, I'm 100% sure if you stop by my office to know that you're there. I do like to spend a little bit of time talking about assistance. I like to try to create a very open environment in my classroom where people feel comfortable and confident in answering things and getting assistance from me and from each other. It's okay if you were an expert in this, you wouldn't be taking the class. So anytime that someone says something that is not correct, don't worry about it. The goal for me is to help understand where all of you are, and an incorrect answer very much helps me to understand what additional content I need to cover, if I need to go back to something that I've said and try to say it in a different or more accessible way. That very much helps me. So please do not feel, to whatever extent possible, like it's bad to give an incorrect answer. If you find yourself starting to struggle in the course, because I tend to have more difficult and demanding courses than average, but I also want to provide you with the support that I can during that process. That's how learning happens. But feel free to reach out to me. Just say, I'm struggling. I don't know where to go or what to do about this. Can I get some assistance? Do that as soon as possible. As soon as you feel yourself starting to slip like that, I am here for you. I will do anything in my power to help you recover from that and do the best that you can in the course. I will not take that personally. I will not judge for any of that. Just know that I am here for you, and I want to see you succeed. So lecture, we're all here, which is great. I like to say that attendance of course lecture is mandatory. I do not keep track of who is here, who is not. I'm not going to babysit. We're all adults, we all have our own schedules, and you're capable of prioritizing your own life without micromanagement from me. I just ask that if you are going to miss, especially an extended period of time, please just send me an email so that I can keep up with you, that I can meet with you when you're back to get you caught up. Life happens, and I understand that life happens. I do also offer the ability to attend remotely via Zoom, just like one person is today. You will all have that opportunity throughout the quarter. If something happens, if your car breaks down and you can't make it to class, if you have some kind of arrangement that has to happen immediately before or after class that makes it difficult to attend class in person, I do want you to be able to attend remotely. That said, I have offered just this freely in the past, and then more than half of the class ends up attending remotely on a daily basis. This is not great for people's learning, so this quarter I would like to keep it to kind of an emergency basis. Just let me know that something has gone on, send me a quick email, and then I will let you attend remotely for the day. I also plan to record class lectures and upload them to YouTube. You'll have the ability to go back and look at those ahead of an exam or any other part, any other kind of evaluation. So you should have plenty of access to the course content. Grading policy is super straightforward for the course. I've split it right down 50-50. Half your grade is going to be homework. Half your grade is going to be 3 exams. They will take place in approximately weeks 3, 6, and 9 and 10. I don't currently plan for there to be a final in the class. I want that last exam to basically cover everything that we've done to date. I've also set aside in the calendar kind of the last week of the class to be a practice problems / apply everything that you've learned from the quarter. So instead of there being content right up until the end of the course, I want there to be some time at the end of the course to say, what have you learned from the entirety of the course? Let's find some problems where we can go apply this in a real world setting, or even something like an interview type setting where you're asked to code on the spot. And that's very difficult for a lot of computer scientists. So I'd like to give people the experience of the real-time coding of a question that you might be asked in an interview setting for an internship or for a job. Homework, I plan to give approximately weekly homework assignments. This is my first time teaching this course here. I've taught it at other institutions. I don't fully have the exact homework schedule outlined at this point. So to the best of my knowledge at this point, there will be about weekly assignments. I reserve the right to change that up a little bit as we figure out how the course is going. I figure out what strengths and weaknesses people are showing. If there are additional weaknesses that show themselves, I might make up a couple of extra homework assignments to give you that practice to cover that weakness. If I see just incredible demonstrated ability right from the get-go, maybe we end up with slightly fewer assignments. We will see. All of those will be submitted to Canvas. We will have written in-person exams. I do this because it's just much easier from an administrative perspective to have the in-person writing going on rather than doing it on a computer. The reason is, if you're doing it on a computer, I have no idea what else is on your screen, and I kind of have to park myself in the very back of the room and keep scanning people's computers to make sure that you're on task in the exam. I don't want to do that. I just don't like it. So we'll have in-person written exams. They will be closed book, closed notes, but for every exam in the course, you will be able to bring one full sheet of paper front and back that you can put on or print whatever you want. So there should be plenty of room for notes, whatever else that you want. I'm not gonna check what is on those, so you can bring whatever you want on that sheet of paper. I will just make sure that people don't use any electronics during the exam. Obviously, no phones, no headphones. I'll ask people to remove things like smartwatches. If you need to use the restroom, I'll just ask you to leave your electronics on your desk so you can't take those with you. I will do my best to have 1 week turnaround for assignments and exams. That should be possible this quarter. One note with exams, I do collect them after they've been gone over, and that's just to make sure that the questions don't leak out there. I do keep those exams in my office, at least for 4 years. So if you would ever like to see your exam after I hand that back, you're welcome to come to my office and study off of it or take notes from some of your questions and answers from prior exams. Or if in a year or two, you want to come back and see your data structures exam for some reason, I will have that on file. I will be attempting to stick to weekly due dates because I know that depending on how many courses you have, it can be difficult to keep track of due dates and times for those courses. So to the best of my ability, unless it becomes a disruption in the class, in which case I reserve the right to change these, I will try to make homework always due on Wednesdays and exams will always be on Fridays. So that will hopefully help people keep a little bit of, sometimes English completely leaves me, organization for your courses. Hopefully that helps. We have the policies for academic dishonesty. In this course, basically, I expect people to be coding and not generating code via AI. I expect you to be working independently on that coding, so no copying code from each other or from the internet. I expect you to be doing independent work. I'm getting better and better at determining what work has been generated by an AI. And there is one very important part of the course that helps with this. I believe I put this up in exams. If it's not there, I'm going to have to add it. It is not there. So one thing that I've been doing in my courses as kind of an anti-AI cheating measure is that I require that in order to get a C+ passing grade in the course, I need people to get a 70% average on exams. And this is a very unpopular thing. I don't like doing it either, but it really helps solidify the idea of the homework is what prepares you for the exams. If you have an AI generate your homework for you, then you will be less prepared for an exam. Even if you get an A on your homeworks, if you can't apply that in real time on an exam, then it becomes apparent to me that you need additional practice in order to be able to move forward in the CS curriculum. And no one goes back to courses that they've passed before to take them again. No one has any reason to do that, nor would I expect you to. So to get a C+ and move forward, I just expect that you're able to demonstrate a 70% average or better. I do frequently, very frequently, just about every time, give extra credit opportunities on exams. And as I've mentioned before, I am here to support you through all of this. So this should not be particularly scary. I don't want this to be something that people freak out about. But it is something that will help minimize the use of AI and utilize your brains to make sure that you're doing the best that you can in the course. Let's see, I think everything else is pretty standard. I have a planned course schedule here. This is just about what I plan to do for the course. We're going to start out with a bit of a 211 rerun with linked lists, but we're going to be doing a generic linked list. I can actually query the class now at this point, I guess. When you did linked lists, did you code it generically or not?
We did it generically.
Did it generically? Good. So we'll do something very similar. I'll just walk through that at the start of the class to make sure that that's locked in, and that's something that's very important for the APE. So we will also go into sorting and recursion. We'll have exam 1. We'll go into complexity analysis. We'll start talking about other data structures, stacks, queues. I want to spend a little bit of time in week 5, right before the APE, preparing people for the APE to make sure that you have the best chance that you can to pass the APE. Because at this stage, having to retake the APE is probably very close to a dead quarter for you. Because you can't take any courses that require either 300 or 212 as the prerequisite without passing the APE. So I want to make sure that you are in the best position that you can to do well on that, so that you don't have to retake it over, because that sucks. We'll go into more advanced data structures after the APE, hash tables, doing some advanced sorting. We'll talk about trees, binary search trees, graphs, and then, as I mentioned, that week 10 will be a lot of time applying everything that we've gone over to kinds of problems that actually utilize everything that we've talked about for the quarter. This material is super important. So I'm really excited to be on this side of the class, helping you to do the best that you can to understand it and be ready to apply it for the rest of your professional career. Are there any questions about anything that I've gone over, syllabus, course expectations? I don't like spending too much time going over the syllabus. This will be up on Canvas. I know I haven't made the Canvas public yet. I plan to do that hopefully right after class. And then this will also be up there for your perusal and reference. The course schedule may change throughout the quarter as I determine maybe we need a little bit more time on something, a little bit less time on something. So things will change. Keep note of Canvas announcements and my in-class announcements. That will be the major way for you to know what's due and when and what we are covering. This is just my best guess at what we're going to be doing and when at this point. But things will evolve. That is a good question, Chris. I appreciate the question. So I will be sending the exam on to proctoring in Genie. I think I can just email it to them. They will print it and be able to get it to you. On Genie, they have exam proctoring services, so I will have much more information for you about that as we get closer to the exam, but you will have the ability to take it in Genie.
Okay.
Other questions or concerns? Let's see how this goes. Okay. So I don't like to waste a ton of time even on syllabus day. There's gonna be plenty of content to cover in the course. If I end up having covered everything sooner than I expect, then we'll handle that then, but I'd like to at least cover my bases here. So we talked about the syllabus. It's just a syllabus. What happened to my, well, this won't matter too much. I like to animate my slides a bit, but it seems like they didn't save when it was. That's not too bad. So what is a data structure? We should probably start there. So preconceived notions of what they are, I guess it would help if this were animated, but a data structure is basically just a way to efficiently organize data. We want to be able to process the data, we want to be able to retrieve data and store data effectively and efficiently. The most important one starting to move forward is efficiently. Because up until this point in your CS education, you haven't really needed to be efficient. If it was a correct implementation, that was good enough. And starting in this class, that will start to change. There are many different implementations out there of the same thing, and you will start needing to know the difference between something that is efficient and something that is not efficient. So we'll start introducing that concept throughout the course. So some examples of data structures that you have seen so far in your education would be something like an array, Java's built-in array list, the linked lists that you've covered, you've seen the three of those, and those are ways to store and retrieve data, as you might imagine. Examples that you probably haven't seen, maybe you have, but maybe you are aware of, is the stuff we're going to cover for the rest of this course. Stacks, queues, hash tables, trees, graphs, and heaps. There are many more, but these are the most important baselines. Questions on anything here about what a data structure is? I will be uploading all slides to Canvas as well, so you don't need to worry about taking word for word notes about everything that is here unless that is useful to you. In my opinion, it's more useful to take notes on the things that I say, since I will probably go on tangents from whatever is exactly on a slide, and a lot of that information will also be relevant and useful. I try to keep as much of the really relevant material on the slide, but I will often say things that are not exactly that. So lots of data structures, lots of different kinds of storage that work in different ways. And we'll talk about all of these. So purpose of the course as a whole, think of it like a really unkempt room, a really dirty, messy, disorganized room. The less organized something is, the longer it takes to find it. If you have an excellent planned storage system, you can locate something extremely efficiently and easily. There's also a place for something. You can also imagine that if a room is very disorganized, how long does it take you to put something in the room? The answer is not very long. You just toss it in the room. It doesn't matter where it is. It's just a messy room, so you can add to the mess by tossing it anywhere. It's very efficient to toss something into a dirty room. But how easy is it to locate something in that dirty room? It's going to be significantly harder to do because you have to dig through the piles of mess. Is this what I'm looking for? No. Is this what I'm looking for? No. There's no place for the item, so locating it is significantly more difficult. Whereas with a very organized room, it takes a little bit more time to put it away. You can't just toss it into the room. You have to figure out where does this item go and put it in the appropriate place. But then when you go look for the item, you don't have to look at everything else. You can just go look for where it goes. I'm looking for the item. If it's anywhere in this room, it's going to be right here because it is organized, which makes retrieval very efficient. So we're going to find this throughout the entire quarter. There are significant trade-offs to every design decision that we make. You need to be aware of what that trade-off is, what the benefits of that are, what the detriments of that are. There's no right way to do it. There's a right way given a bunch of constraints, given what your client is going to need. I'll try to give you an example of this. So let's use the dirty room example, where it's either dirty, which means that putting something in the room is very easy, and finding something that's in the dirty room is difficult. Or the organized room, where putting something away takes a little bit more effort, and retrieving something is much easier. You can imagine being in a situation where you need to put things away significantly more frequently than you need to retrieve them. In that case, what storage do you want? Do you want the dirty room or do you want the organized room?
Dirty.
The dirty room. It makes a lot more sense because you're going to be doing a lot more putting things in than you're going to be taking things out. So you want the efficient part of this to be the depositing the item into the room. On the other hand, if you're going to be doing a lot more retrieving of items than you will be putting them away, you want the clean room rather than the dirty room, because that is going to be much more efficient. So there's no one right answer to which storage you need. It will depend on what operations you intend to be doing more or less frequently. So as said on the slide here, gains in one metric are often met with counteracting losses in another metric. So shoving clothes into a dresser, shoving stuff into a room, something like this makes a lot of sense with regards to how efficient is the whole system based on the kinds of operations that you expect to be doing. So we're going to be looking at many commonly used data structures and their applications. We're going to be using a lot of advanced Java in here from 2.11, as well as some additional stuff. We're also going to be using a lot of math to be able to describe the efficiency of things. That's how math comes into computer science a lot. If you need to be able to tell someone how efficient your structure is, you need some way to represent that. And math is really the universal language. You can tell someone how efficient something is and say, trust me, it's very efficient, and no one is going to have any idea what that means. Whereas if you're able to relay that information mathematically, people will have a precise notion of how effective and efficient your structure is. So we want to be able to talk about that efficiency in a language that other computer scientists will understand and appreciate. We want to be able to do that for every operation within a structure, as well as talking about the structure as a whole. So this idea will be extendable to every algorithm you've ever written or will write in this course and courses beyond this course. It's worth talking about abstract data types, and unfortunately, this is the saddest part of this course. I was going to have a fun class exercise and have this real question hidden in the end, but let's go ahead and do this process for fun. So go ahead and draw out this structure as you go through this process. So this is a list. You should insert 16 at the end of the list, then insert 9 at position 0, then set the element at position 1 to 22, and just continue this process until the very end. And then make sure that your final list makes sense to you, that this list has all of these structural components. And pretend over this bottom doesn't exist. Now that I say that, everybody immediately looked at it. What is it? Yeah,
Do we start with just an empty list?
yeah, sorry, just an empty list. Sorry about that. Also, Chris, I apologize, I'm talking to the remote person. The camera in the room is not working today, so my workaround was just to share my screen, so I'm probably gonna be drawing this on the board, and usually you would be able to see this. I'm gonna be putting in an IT ticket today to make sure that the camera gets fixed for the future. Normally, you'll be looking at the screen so that you can see both the slides and the stuff that I draw. This is just my temporary workaround for the camera not working, so I apologize.
Oh, good. Thank you.
All right, we have answers. What do we get?
9/22/18.
All right, let's take a look at this. Do we have agreement, disagreement? 9/22/18?
Nine, 12, 16.
Let's go through this process and see how it works. Hopefully this pen, I forgot to bring my pens, I'm gonna start doing that again tomorrow. Hopefully this works. Looks like it's good enough. All right, so we have an empty list. We're going to insert 16 at the end. So we're gonna have some box that has 16 in it. We want to insert 9 at position 0. So when you insert something into a list, everything that exists in that list is pushed toward the end. So after this second step, we're going to have 9 at position 0 and 16 at position 1. We then want to set the element at position 1 to 22. So we have indices on this. This is index 0, index 1, index 0. So we want to set the position, the element at index 1 to 22. So we should have 9 at position 0 and 22 at position 1. At the end of that step, then we want to insert 12 at position 1. That's going to make an extra element and push everything past it toward the end. So we're still going to have 9 here, but we're inserting 12 at position 1. So we should have 9, 12, 22. We want to insert 18 at the end. 9, 12, 22, and 18. At positions 0, 1, 2, and 3 now. And now we want to remove the element at position 2. So we're going to get rid of the position at element 2. We're just going to move everything else in the list back toward the beginning at that point. We have 9, 12, position 2 got deleted, 18. Should be the final list. Other people get this? All right, so this is a just good practice of emulating the operations of a data structure, but note that this didn't specify any kind of implementation. I've kind of drawn this out like it's in an array, but did we really need to draw this out like it was in an array? Could we have used a linked list type drawing instead here? We could have made something that said 16 and an empty pointer to a next. And we could have drawn 9, 16, and we could have continued this process using it like a linked list rather than an array. So it does not matter whether you pick what kind of list you use to draw this out. So if you've heard of, and you should have heard of, interfaces in 211, right? This is an example of the application of the list interface. The list interface defines a set of operations that we can do to any list. We can insert, we can set elements in a particular position, we can override their values, we can remove elements, and any implementation of a list is able to do those things. But nowhere in these instructions did it specify which one of those we were going to be using. It didn't specify we're going to be using an array for this, or we're going to be using a linked list for this. You can see how it doesn't matter what the actual implementation is, as long as somewhere there's a definition that says, if you're using an array list, here's how you do these things. If you're using a linked list, here's how you're doing these things. So the interface just specifies what things can we do, and then what implements that interface specifies how we do those things. So the array would specify exactly how to manipulate the elements of the array to make sure that we were able to do this sequence of steps. On the other hand, if you have a linked list, there'd be a separate set of logic that tells us how to manipulate this. If you're using an array, you never need to worry about something's next. But you have to worry about whether or not you're doing something that's within the array's bounds. A linked list, you don't really have to worry about whether you're doing something inside of the allowed bounds, but you do need to worry about these connections between these node objects. So that to me is an explanation for how an interface works. So we can see that this is built into the Java language. By going here, we can see exactly what a list can do. And let's say that you've had this genius idea. You say, I hate arrays, I think they suck. I hate linked lists, I think they suck. I've come up with this new idea of a list, a new structural way to do this, and you would like to be able to implement it. In order for it to be a list, you would need to make sure that it has the ability to support everything that any other list can do. You need to be able to insert at the beginning, at the end, at a specified position, remove from the beginning, the end at a specified position. The logic for how to do that would be your algorithm. This would be the thing that you invent and you could then use. You would be able to follow this exact sequence of instructions and come up with some internal representation of what that would look like. Questions on anything from this concept of the list interface and which type of list we choose to do with it, how that logic differs, but we factor out the concept of what are the instructions into an interface? We don't specify how to do those instructions because then it wouldn't apply to the other kinds of lists. If the interface had the instructions for how to do this in an array, then we wouldn't be able to do it as a linked list. If the interface specified how to do it for a linked list, we wouldn't be able to do it with an array. So we're factoring out all of this information into the interface for what do we need to define how to do in order for our structure to be a list. So we call this an abstract data type. An abstract data type is a list. It's not an array list or a linked list. Those are implementations of this abstract data type. But a list is this abstract idea of the types of whatever we need to implement to be able for this to be a list. We need to be able to define how to insert at the end, how to set an element in a position, how to remove an element out of position. Questions? All right, so an interface, this is just review from 211, hopefully. We're defining the necessary fields and methods for, the idea is cross-compatibility between the implementing classes. So with the instructions that we had on the previous slide, you could take those instructions and implement them like an array or implement them like a linked list. So we're defining what needs to be possible in order to implement this abstract data type. So one interface for abstract data type, and every data structure that we cover in this class will be an abstract data type. There will be multiple different possible implementations of that abstract data type. So we will start talking about things like a stack. There are multiple ways that you can implement a stack. It just has some stuff that you need to make sure that you're able to do for it to be a stack. You can think of it also like we are all individual people, yet we are all human. We all have a certain number of characteristics that we all share in common in order for us to be a human, but the actual implementations of those things are different, which create the differences among us. Yet we're still all human. We still adhere to the human interface. Questions on interfaces? Well, we are basically out of time. I don't want to dive too much into the next topic, but we're going to start talking about generics. We're going to implement a generic linked list in class, and we will go from there. Thank you, everyone. I will see you all tomorrow.